Professor Bialis here. In this video we're going to be talking about section 4.3 where we're solving systems of equations using the addition method. When I learned this years ago it was called the elimination method. You'll see why. We sometimes call it addition, sometimes call it elimination. But it's another algebraic method of doing things. We had substitution in section 4.2 and that works just fine. Sometimes the problem with that though is, as you saw when we were doing those problems, we started with equations this long, and then when we substitute them together, they get this long. When we do the addition or elimination method, you'll see that it flows out very nicely. It doesn't ever get you'll never get a really long equation. Okay, so when we did substitution, we needed to start with a variable by itself. With elimination or addition method, we want to have the equations lined up. Okay, so first thing is, we must have the equations lined up. Okay, we must have the equations lined up. Let me show you an example and I'll explain what I mean. Okay, and again, all we're doing in this video is solve using the addition method. Okay? So, we want things lined up. What I mean by that is exactly what we have here. We have x's, we have y's, we have the equal, we have the constant. Okay, all of those components must be lined up. Now, what we're doing with the addition method is literally just adding down those columns. Why we're allowed to do that is because this x minus y is the same as 5. So what I'm technically doing is adding this expression to this side of the equation and this expression to this side of the equation. What you do to one side, you do to the other. And we're doing the same thing because they are equivalent expressions. Okay? So bottom line is we're adding down the columns. But what is kind of underlying that is the fact that we're adding the same thing to both sides. Okay? So when we add these columns up, watch what happens. We have x plus x is 2x. A lot of people just drop that down and put x. Make sure you actually add them. But then y minus y, what happens? They eliminate. Okay, and that's why sometimes this is called the elimination method. Okay, we're using addition to get things to eliminate. Equals 13 plus 5 is 18. Now look at what happened. When we did substitution, our goal was to take these two equations with two unknowns and mesh them together so we have one equation with one unknown. That's exactly what happened here. We used a different, methodology for that, but we combine these to get a new equation with a single variable. And look at how nice and short that equation is. So what I'm going to do is I'm going to divide by 2. X equals 9. Good to go. Okay? Now, the drawback to this is when we were doing substitution, to get that second variable, there was always an equation that had that variable alone. We don't have that here. Okay, so pick one of the equations that you see up there and use it. So I'm going to go after this one. I'm going to avoid this just because of the minus that's there. So I've got x plus y equals 13, or 9 plus y equals 13. And y equals 4. And what I get is my ordered pair solution, 9, comma 4. And there we go. Okay? Now, what's going to happen is when we go through more examples, you're going to see that these things don't eliminate on their own. We're going to have to make that happen. So that's really where the inner workings of this method come through. So let's look at another example. Now, the good thing about this is it's already lined up. However, if I were to add down these columns, does anything eliminate? In this case, no. Okay, we would get a x and then a 3y. We still have those two variables. That's a problem for us. We need to have a single variable left over. So, when something doesn't eliminate, we need to first make a decision. What do we want to eliminate? Again, there's no wrong answer here. Sometimes there's better answers than others, but in this case, it's going to require the same amount of work either way. Let's just say I want to eliminate the x's, okay? I want these to eliminate. Now, why did these eliminate? These eliminated because they were opposites. We need to make these opposites. So we have a 2 and we have a -1. To be opposite, we're going to be looking for a common multiple, almost like a common denominator. And that common multiple is going to be a 2. So what I'm going to do is I am going to multiply this whole bottom equation by a 2. Okay? Again, if I do the whole thing, I'm multiplying both sides by 2. That's a legitimate move. So what I end up with is 2x minus y equals -6, then -2x plus 8y equals 34. Okay? Now look what happened. Now these x's are opposites. Okay? They have to be the same number, opposite signs. And once I get that, 2x minus 2x eliminates. -1y plus 8y is 7y. -6 plus 34 is 28. And then I can divide by 7. And there's your y value. To get the x value, you can go into this equation, or this equation that we got down here. Okay, whatever is easiest for you, you go with it. I'm going to go with this first one. Okay, so I've got 2x minus y equals -6 is then 2x minus 4 equals -6. Add the 4. 2x equals -2. And then divide by 2. So what I get is x, comma, y, and there we go. Okay? One thing I want to also kind of make you aware of, all of these systems, we could have solved these for y and graphed them. We could have found one variable, get it by itself, use substitution. We could use addition. All of these methods are usable. Okay? These are just different strategies. Okay? Different tools in the tool belt. If I wanted to build a house, can I build a house using a hammer? Yes, but a nail gun would be nice to have. Okay? However, if I don't have a hammer, that's a problem too. So I want to have as many tools at my disposal as I possibly can have. Okay? So let's look at another example. Okay, so again, we look at it, it is lined up, which is nice. However, we don't have something that eliminates on its own. Okay, so we are going to pick a variable, x or y, to target and eliminate. There's no wrong answer to that, okay? But see, sometimes one of them requires more work than the other. In this case, I would want to multiply this by a 3 to make it match, okay? Here I could multiply this by a 3 to make it match. So either way, it's going to require the same amount of work. Let's target the x's, okay, just because they're in front. So I am going to multiply this first equation by 3. And what I get is 3x minus 9y equals -6. Make sure you distribute onto this as well. That's very important. and then I bring down that second equation as it was given to me. Okay, now look at what happens. I targeted the x's, and in fact, yes, they do eliminate. But the y's also eliminate. So what do I have on that left side? Nothing. But I need to show nothing with a 0. Equals -1. Now we've seen that in the past. Whenever we have two numbers that are not equal, we have no solution. Okay, now I'm going to say the same thing that I said in the section 4.2 video. I would definitely check these problems first, okay? Because it's very easy to accidentally get a no solution. So, to check that, remember no solution should be parallel lines. I would solve each of these for y and make sure they show the same slope but different y-intercepts. Okay, again, I wouldn't do that immediately right after that. I would finish the test or the quiz that you're on, but then at the end I would go back and check that over. Okay? Let's look at another one. Okay. Now, everything's lined up. Nothing eliminates as is. If I go after these x's, to make them match, I would have to turn them both into a common multiple of 12. That would require multiplication on both of them. To make these match, I would have to make them a multiple of, or the common multiple of 10. Okay? I would have to multiply both of them. So in both of these cases, they require the same amount of multiplication. However, I would suggest go after the y's. The reason for that is because it's not enough to make them match numerically. They need to also have opposite signs. These already have opposite signs. Could I throw a negative and multiply this by, let's say, a -4 to make it a -12? Absolutely I can. But then I have to distribute a negative. That's one more thing that I have to do that I could possibly make a mistake on. So my suggestion to you is I would go after these because they have the opposite signs already. So again, a 5 and a 2, I want to make them both a 10. That's their common multiple. So I'm going to multiply this top one by a 2 and this bottom one by a 5. Notice what happened there. Do you see how I kind of flip-flop the 5 and the 2? That will always work, okay? However, that may sometimes give you a bigger number than you need to use. So if you're struggling with, oh, I don't know what number I'm trying to make them both become, then don't worry about it. Just literally switch, switch. Okay, that will work. It may not give you the smallest, but it will work. Now, let's find out what we have left. Distribute a 2. I have 8x plus 10y equals 28. I have 15x minus 10y equals -5. Now, I was targeting the y's, and the y's cancel. Those are gone. I get 8 plus 15 is 23x. 28 minus 5 is 23. I can divide by 23. And x equals 1. Now I need to find my y. I pick this equation, this equation, this equation, this equation. All of those will give me the same y when I plug that x in. Okay, so I'm going to go with this top one. Okay, so I'm going with 4 times x plus 5y equals 14. Plug in the 1. And then I solve from there. So I get a 4. I subtract a 4. And then I divide by 5. So that gives me an x, comma y. And there's our final answer. Okay? Now, and as always, I push the checking on these. If you want to check this, you plug in a 1 here, a 2 here. make sure that gives me a 14. Plug a 1 here, a 2 here, make sure that gives you a negative 1. Okay, and if you're trying to practice your mental math, this is a great place to do it. Okay, everyone's saying, oh, I'm not good at you know, doing all that calculation in my head. That's okay, but we need to practice that then. That's something that's a skill that I don't care who you are, what you're doing. That's a skill that we all need. Okay, and we need to put that into practice. Okay, so checking that's the time to really make use of that concept. Okay, so let's look at a couple more. Okay, so for this one, notice the x's and the y's, they both have the opposite signs. So we just have to pick one. Let's go with the x just because it's in the front. I'm going to try and make these both become a 4. Okay, this one already is. So I'm going to multiply that top equation by a 2. Okay, now be careful with that distribution. I have 4x plus 10y equals 2. Don't forget to distribute all the way over to that constant on the right side. And then I bring this equation down. Now, I wanted the x's to cancel, but what else happens? Gone, gone, and gone. I have nothing on this side, and I have nothing on this side. Now, in the previous example that was similar to this, we had no solution because those numbers didn't match, but in this case they do. So this is where we have those infinitely many solutions, but that just says how many there are. How do we describe the solutions themselves? That's again where we would say it's a bunch of xy ordered pairs such that, and then you write one of the equations down. It doesn't matter which one because they're all the same equation. I'm going to go with this top one here. 2x plus 5y equals 1. We try to use the equation with the smaller numbers just because they're smaller, nicer numbers. Okay? And that's it. That is your answer. This is your result. This is the interpretation of that result which gives you the answer. Okay, so always take it this last step. Now, as I was saying with the no solution problem, I would suggest checking this one. And you check it by thinking about what this looked like graphically. This looked like two of the same line graphically. So we had one equation, same equation on top of each other. That was what we were getting on the graph. So if we want to check this, solve each of these for y and make sure it's the same equation. Okay? There's nothing to plug back in, but there is some manipulation on these that you can do to make sure they match. Okay? Let's look at one more. Okay. Now, there's fractions. Okay, we've got to deal with them though. Not for very long. Remember, these are still equations. Yes, it's a system, but there's still an equation on the top and an equation on the bottom. What did we always do with fractions and equations? We cleared them out, right? So let's do that. We can think of these as independent equations for at this moment. So this top equation, I want to get rid of those thirds. So I'm going to multiply every term up here by a 3. What that leaves me with is a negative x plus 3y equals 4, because those cancel, and then that multiplies in the middle. Look at how nice that equation turns. How about here? Here, to clear out all those halves, I'm going to multiply by 2. And we get that. Now, what we were trying to do there is get rid of all the fractions. As an added bonus, do you see how these x's cancel out now? That won't always happen. Sometimes you're going to have to clear fractions and then do some more multiplication to make things eliminate. But if it works out nicely, let's go for it. Okay? So 3 minus 5 is negative 2y. 4 minus 1 is a 3. I'm going to divide by negative 2. And I get a negative 3 over 2 for my y. Now I still need to plug back in and get the x. You can plug in any of these equations to get that x. I would avoid these because you got fractions to begin with and then you're plugging another fraction on top of that. Go with one of these, okay? If I'm looking for x, I'm going to pick this one because up here I would have to contend with that negative sign. So I'm going to go with this. X minus 5y equals negative 1. X minus 5 times negative 3 over 2 equals negative 1. Now, take this a piece at a time. Negative times negative is a positive. And then all it is 5 times 3 is 15. And then I carry that 2 over. Because remember, this is a 5 over 1. So 5 times 3, 1 times 2. And then equals negative 1. I then subtract 15 over 2. Okay, now I always tell my students at this point, put the calculator down. Okay, try this out. Whenever we have a fraction and an integer, okay, all we're going to do for that integer is we are going to create a new number with the denominator that's down here. And then we would take that denominator 2, or whatever it is, multiply it by this. 2 times 1 is 2. So forget negative 1. We have a negative 2 over 2. Now we have a common denominator. So it's negative 17 over 2. Okay? So what we get is x, comma, y. And there we go. Okay, so that's the addition method, or I still every so often call it the elimination method. Okay, make sure everything is lined up, and then figure out your multiple. It's the same exact thing we did with common denominators. Okay, but there's no fractions necessarily, so we call them multiples. Do the multiplication, and then you're good to go. Okay, so we have 3 methods for solving systems. Okay, and the systems we've been solving have 2 variables, 2 equations. We call those 2 by 2s. So we have graphing, we have substitution, we have elimination. Okay, pick whichever one you want, but if the instructions specify use this method, use that method. They're all good methods. Don't pick one and stick with it. They all have their time and place. Okay, so as always, work hard. Let me know if you have any questions, and I'll see you next time.